Assalamu alaikum. Today we will talk about section 5.2, which is about the definite integral. Before we start the section, let us recall section 5.1. In section 5.1 we treated the area problem where we need to find the area under the graph of the continuous function y equal f of x from a to b and bounded by the x-axis from below here. Also we had this condition, we need y equal f of x to be greater than or equal to 0. We said to handle the area problem we need to partition the interval from a to b uniformly. That means we find delta x, which is b minus a over n. Then we add delta x all the way, which is fixed here, until we get b. Then we approximate the area. Then we said we can choose our sample point to be right end point or left end point or any point in between, and we call them the general sample points. At the end of the day, we had a formula for the area, which is equal the limit of summation f of xi delta x. In fact, this limit of summation occurs a lot in the application, so we will give it a name and a notation, that is the integral from a to b f of x dx. Let me say a note before we start the section. In 5.1 we had the restriction f of x to be positive or 0. In fact, in this section we will not have this restriction and we will treat the general case. Let us read together. He said here, definition of a definite integral, that is definition number 1. If a function defined for a less than x less than b, we will divide the interval ab into n subintervals of equal width delta x b minus a over n, as we did here. Then we will let x0 to be a, this is over x0. Then we have x1, x2, etc. until xn, and we will call it b. B the end points of these subintervals, and we let x1 star, x2 star, etc. up to xn star be any sample points in these subintervals. And we said this before. This will be our x1 star, and we will pick x2 star from this interval, etc. This is xn minus 1, and this is xn, and we will choose xn star from this last interval. So xi star lies in the I subinterval, as I said. Then the definite integral of f from a to b will be the integral from a to b of x dx equal limit of summation f of xi star delta x, provided that this limit exists and gives the same value for all possible choices of sample points, whether it is right or left or mid or any point in general. Now, if it does exist, we say that the function f is integrable on ab. Let us summarize what we did here. We said we partition the interval uniformly and we write x0 and xn for a and b respectively. Then we have x1, x2, etc. and we said this is delta x all the way, which is fixed here. Then we will choose x1 star from this interval and so on until the last one we will pick xn star. At the day we will have the integral from a to b of x dx, limit of summation f of xi star delta x. Good. This definition is given in the textbook and it is followed by 7 notes. Here is an advice: please read the textbook because I wrote my notes on that textbook. Good. Note number 1. He said if xi star is equal to xi in this definition, then the integral from a to b f of x dx will be the limit of summation f of xi delta x. Simply we change xi star by xi. In fact, this is the right end point definition, and this part only without the limit is called Rn. Also, if we change xi star to be xi minus 1, then we get the integral from a to b f of x dx, limit of summation f of xi minus 1 delta x. See here, we change xi star by xi minus 1. And this definition is called left end points definition. Also, for this integral, we call the number a by the lower limit and we call the number b by the upper limit. The function here is called the integrand, and dx indicates that the independent variable is x. That means we integrate the function with respect to this variable x. Note number 3. The definite integral from a to b f of x dx is a number. It does not depend on x. Let me give you an example. The integral from 0 to 1 x dx. We will verify this today or in other sections. This integral is equal to half. This is a real number. Also, in fact, we can use any letter in place of x without changing the value of the integral. That means change x by t or anything you like. The integral value will not be changing. Here is an example. The integral from a to b f of x dx is the same as the integral from a to b f of t dt. We change the x by t, and here we change it by r. All of these are equal. Just to see this example here, the integral from 0 to 1 x dx is the same as the integral from 0 to 1 t dt, which is equal to the integral from 0 to 1 r dr. All of these are equal to half. Note number 4. The summation from I equal to 1 up to n f of x I star delta x is called a Riemann sum. That means we remove the limit only here. In fact, these are called Riemann sum after the German mathematician Riemann. Note number 5. If f of x greater than or equal to 0, then the integral from a to b f of x dx is the area under the curve y equal f of x from a to b. And you can see this figure or see this. Since y equal f of x greater than or equal to 0, then the integral from a to b f of x dx will represent the area. One will ask this question: what about if we do not have this condition? Will the integral represent the area under the curve? Let us see the following note. Note number 6. In general, if f takes on both positive and negative values, then the integral from a to b f of x is the net area bounded by the curve and the x-axis from a to b. What do we mean by the net area? Let us read. That is the sum of the areas of the regions above the x-axis and the negative of the areas of the region below the x-axis. See here, please. The sum with those above and negative with those below the x-axis. See figure number 2. If we were asked to find the integral from a to b f of x dx, then it is equal to the net area. What is that? You will sum those areas above the x-axis, that is a1 plus a3. And for those areas below the x-axis, you will put a negative before the area. So the answer will be a1 plus a3 minus a2. Note number 7. The areas are always non-negative, a greater than or equal to 0. But the Riemann sum or the definite integral f of x dx may be positive, negative, or 0. The integral f of x will be positive if the areas above the x-axis are greater than those below. And it will be negative if you have the other way around. That means the areas below the x-axis are greater than those above. And it will be 0 if the areas above the x-axis are equal to those below the x-axis. Let us see an example quickly. He said, given the graph of f, find part A, the area bounded by the curve y equal f of x and the x-axis. Here is the graph. This is 0, this is 6. For sure, we have a triangle number 1 and we have triangle number 2. So, the area will be what? In fact, it will be a1 plus a2, where this is a1 and this is a2. a1 is equal to what? This is a triangle, so we will multiply half by base and height. The base here is 2, and height is equal to 1. Plus, what is a2? Half times base. The base is starting from 2 to 6, that is 4. And what is the height? You can see it here. It is running from minus 2 to 0. And what is that height? It is 2. So this is simple computation. You can do this. You will get 1 plus 4, which is equal to 5. So this is the area bounded by the curve and the x-axis. Now, part B. if we ask you to find the integral from 0 to 6 f of x dx, what shall you do in this case? See here, it will be what? It will be the net area, that is a1 minus a2, which is equal to what? a1, remember, it is 1. What is a2? It is 4, but do not forget this minus sign, so the answer is minus 3, which is negative. Why this is negative? Simply because the areas below the x-axis, which is a2 in this case, is dominating the other area. Now let us see question number 2. He said, given the graph of g, find the integral from 0 to 2 g of x. You can see it here. This is the function g of x, this is 0 and this is 2. Clearly we can see the function above the x-axis, so the integral will be exactly the area, a1. So what is a1? It is half times base times height. This is the base, this is height, and these are the computation. Part B, we need the integral from 2 to 6 g of x dx. This is 2 and this is 6. Clearly the function is below the x-axis, so it is a2, but do not forget to put a minus here. So if you calculate this, it will be half by r squared, because this is half a circle, and the radius, you can see it here, it is running from 2 to 4, that is 2. Great. Now let us see part C. He said find the integral from 0 to 7 g of x dx. Well, there is the net area. Be careful. It is a1 minus a2 because it is below, plus a3 because it is above the x-axis, and these are the computation, and they are very simple. Let us see theorem number 1. It says if f is continuous on AB, or if f has only a finite number of jump discontinuities, then f is integrable on AB. That means the definite integral from a to b f of x dx exists. So in this course mainly we may concentrate on the first part. If the function is continuous, then it is integrable. Rarely we will see the situation where we consider a finite number of jump discontinuities. Concentrate on the word finite. So for example, assume we have this function, for example, from 0 to 1, and there is a discontinuity here, which is jump discontinuity, and the function continues this way up to 2. In fact, we can integrate this function. It is integrable function. What about if we have 2 jump discontinuities? It is integrable. What about if we have 1 million jump discontinuities? Again, it is integrable because it is finite. Good. Now let us see this remark after theorem number 1. If f is integrable on AB, then the limit in definition number 1 exists and gives the same value no matter how we choose the sample point xi star. That means this integral from a to b f of x dx, if you evaluate it using limit of summation, then you will get the same answer, whether you evaluate it using right endpoints or left endpoints or midpoints. The author of the textbook says, to simplify the calculation, we often take the sample points to be right endpoints. In this case, everything is simplified to theorem number 2. Recall, xi star will be xi using right endpoints. Theorem number 2 says, if f is integrable on AB, then the integral from a to b of x dx will be limit of summation f of xi delta x, where delta x is equal b minus a over n, and xi is a plus I delta x. This theorem is very important, and you need to memorize this representation because it occurs a lot. Now, let us see question number 3, which is application for this theorem. He said express limit of summation as a definite integral on the interval 0 to 1. Now let us see, how can we change from this form to this form? I think this is easy for us. We will change limit of summation to integral. Simple. Delta x will be dx and xi will be x. Let us apply it in this example, and I wrote it here for you. Replace limit of summation by integral, replace xi by x, replace delta x by dx. If we do it, limit of summation, change it to integral, xi change it to x here and here, delta x make it dx. That's it. This is the answer. No need to write anything. Also, we have an example here. I will leave it for you. Check it. You can solve it in 1 second. Now we will start with this part of evaluating integrals. When we use a limit to evaluate a definite integral, we need to know how to work with sums. The following are formulas and rules for working with sigma notation. Here you can see that we gave you a formula for summation of I, summation of I squared, summation of I cubed. And according to our syllabus, you need to memorize all of these three. And I will explain them in the next point. Let us understand this first. Summation of I equal, if you put 1 here, you will get 1, plus, put the next index, which is 2, you will get 2, plus, dot, dot, dot. What is the last one? It is n. He said this is equal to n plus 1 over 2. And let me say something. Do you see this last number n? Put it here. And here, add 1 divided by 2. Let us take an example here. What is summation of I? I equal to 1 up to 3. Simple example. If you put 1, you will get 1. Add, you will get 2. We need to end with 3, so we are here. Add them, you will get 6. Now let us apply the formula. What is our n? As I said, it is the last number here, which is 3. So put it here. Put 1. Add 1 here. You will get 4 and divide by 2. If you evaluate this, 12 over 2, that is 6. So we get the same answer. Good. Now let us see the formula for summation of I squared. In fact, we had this in section 5.1. Summation of I squared equal n plus 1 to n plus 1 over 6. Summation of I squared is equal, as we said, it is 1 square plus 2 square plus dot dot dot, and we need to finish with n square. According to the formula, it is n plus 1 to n plus 1 over 6. If you need an example, you can see here, I gave you summation of I square, I equal to 1 up to 4, 1 square plus 2 square plus 3 square plus 4 squares. If you evaluate them, you will get 30. Or apply the formula. Note here, our n is 4. So put it in the formula here, you will get 4, 4 plus 1, 2 times 4 plus 1. You can see the computation here, divided by 6, we will get the same answer, 30. Also, we have a formula for summation of I cubed. The formula is given as follows, n plus 1 over 2, then we have square here. Just to memorize it, we just put this here and we put power 2. If you need an example, see this here. Also, we have formula for summation of C, of a constant C. The answer is given C by n, where n is this number here. What is the proof? Here we have summation of C. We will start substituting I equal to 1. There is no I here, so just write C plus. Substitute I equal to 2, but there is no I, so put C plus dot dot dot, and the last one we will put C. How many C's here? For sure we have n of them, so I will write n times here. So the answer will be n times C, or C times n. Also, we have summation of CAI is equal C summation of AI. That means you can pull out the C outside the summation. Let me give you an example for illustration. Let us substitute directly. If I equal to 1, you will say 4 times 1, that is 4, plus. Substitute 2, you will get 4 times 2, that is 8, plus substitute 3, you will get what? You will get 12. Add them up, you will get what? 24. Now, let us see the right hand side. When we pull the 4 outside, what do you get? You will get 4. Take a bracket here. Substitute 1. I think we already did this. This is 1 plus 2 plus 3, 24. So they are the same. So it's like you are taking the common factor 4. It is 4 times 1. 8. We took 4 times 2. So here, it's like you are taking the constant outside the summation. Note number 6. Summation of AI plus or minus BI is given by what? Summation of AI plus or minus summation of BI. That means you can distribute the summation over the sum or the subtraction. Great. Now, we will use these formulas in the following example. But first, let us consider question number 4, part A. He said, evaluate the Riemann sum for f of x, which is equal x cubed minus 6x, taking the sample points to be right in points and a equal to 0, b equal to 3, and n equal to 6. That means the interval is from 0 to 3 and use 6 rectangles. Let me say a note. This example will be solved the same way as example number 1 in section 5.1. There, the question says, estimate the area for f, and we will give you a non-negative function. In general, if the function is changing sign, we will ask you about the Riemann sum. And it happens that this function is changing sign. So let us start solving. First of all, we need to find delta x, which is given by the formula b minus a over n, which is in this case 3 minus 0 over 6, which is equal to half. This is your b, this is a, and this is your n. Now, add delta x to a, you will get half. Add it, you will get 1. So you will get this computation. And here we will finish with 3. Now, he said use right endpoint. So what is my right in the first interval? It is half. So we will take it. What is my right in the next interval? It is 1. I will take it. And here I will take 3 over 2. And here I will take 2. And here I will take 5 over 2. For the last interval, my right is 3. So as we said before, take all the numbers except the last one on the left, because we are using right endpoints. Now, what is R6? Because we are using right endpoints with 6 interval. This is equal what? It is delta x times f of these numbers. If you evaluate this, delta x is half, f of half you can substitute in the function. So you will get minus 3.9375. And the answer here is negative. Why? Why this is negative? Let me illustrate it here. First, you can see the function is sometimes negative and sometimes it is positive. That means above the x-axis. When we create our rectangle, let us start by half. So you will start from half, you hit the curve and you go to the opposite side. See here, we hit the curve, we are going below because the function is below. Similarly here, start from 1 and hit the curve and go to the opposite side, etc. until you get, for example, in the last interval at 3, which is with us. So you hit the curve and you go to the opposite side. So here, sometimes you will have rectangles above the x-axis and sometimes you will have rectangles below the x-axis. Here, the yellow rectangles dominates the blue rectangle. So we expect the Riemann sum to be negative. Is this clear, Shabab? In part A, we use 6 rectangles. In part B, we will use n rectangles, then we push the number of rectangles to infinity. That means we will evaluate the integral of that function. Part B, he said evaluate the integral from 0 to 3 x cubed minus 6x dx using the right endpoint definition within subinterval. Later on in the course, in section 5.3 and 5.4, we will evaluate this easily. But for the time being, we are limited to solve it using the definition. What is the definition? I hope you still remember this. The definition says the integral from 0 to 3 x cubed minus 6x dx is equal limit of summation f of xi delta x. So let us have a step before this. What is my delta x? Delta x, it is b minus a over n, which is in this case 3 minus 0 over, this is your b and this is your a. So which is equal 3 over n. Similarly, we will find xi, which is by the formula a plus I delta x. My a is 0 and my delta x is 3 over n. So let us put it here, 0 plus 3i over n. Right? If you simplify it, you will get 3i over n. Now put everything in the formula and that's it. Here for sure we will have the summation from I equal to 1 up to n, and here when n goes to infinity, which is equal the limit of summation if, what is my xi? It is 3i over n. I am just substituting. Delta x is found to be 3 over n. That's it. Now let us simplify a little bit. This is the limit of summation. What is my function? It is x cubed minus 6x. So first cube whatever inside the function. So if you cube this, for sure you will get 27i cubed over n cubed minus 6 times this. The 6 times this will be what? 18i over n. Correct? And do not forget, you need to multiply everything by 3 over n. Now simplify and we are done. So this will be limit of summation. First of all, let us multiply this term by this term. 27 by 3, this will be 1i cubed over n to the power 4 minus 18 by 3, this will be 54i over, and you have downstairs n square. Now you can do what? You can distribute the summation. Summation of this minus summation of this. So this will be limit summation minus another summation. What do we have here? We have 81i cubed over n to the power 4, and here we have 54i over n square. Now I will do another step inside this step. Let us take the constants outside. Remember, the summation depends on what? In I. So anything other than I, you can pull it outside. So allow me to take this 54 and this n square outside the summation. So we are left with what? With I here. And similarly here, let us take 81 over n to the power 4 outside the summation, but not outside the limit. Be careful, because the limit depends on n. And this is n to the power 4 and this is I cubed. That's it. We are done with the question. Now, summation of I cubed, it has a formula, right? Which was what? N squared times n plus 1, check this in the note, over 4. Do not forget 81 over n to the power 4. Minus 54 over n square. Summation of I is n plus 1 over 2. And that's it. This is the limit when n goes to infinity. Either you simplify or you can see this. This is a polynomial of degree what? N squared times, if you expand this, you will get n squared. So this is a polynomial of degree 4. And this is polynomial of degree 4. So what is the limit at infinity? This is very simple. You just take the leading. The leading upstairs is 81 over the leading downstairs, which is what? 4 minus. Similarly here, this is n times n. You will get n squared. And this is n squared. So this is again polynomial of degree 2 over another one of degree 2. So just take the leading. The leading upstairs is 54 and downstairs is 2. This is simple computation. Take the common factor 4. You will get 81 minus, and here you will get 108. If you calculate this, you will get minus 27 over 4, which happens to be negative number. What is the reason for the negative number? I wrote it here as a note. First of all, see the graph of the function. Sometimes it's negative and sometimes it is positive. So remember, the integral represents the net area, which is minus a1, because in this region the function is below the x-axis, plus a2, because in this region the function is positive. See here, a1 is dominating a2, so we expect that the integral to be negative. Is this clear? I hope you enjoyed. Now, if you see the recording, this is exercise for you. Please do it. He said evaluate the Riemann sum for this function, f of x equal x squared plus 1 on 0 to 2, taking the sample point to be right endpoint. Let me remind you, this question is the same as the previous one, but without the limit, because we said find the Riemann sum. This is the solution. I hope you can follow it easily, and that's it. And also we have part B. If we said evaluate the integral, you just take the limit of Rn. So part B is very simple. Now just concentrate on part A. I hope you can do it yourself. Thank you very much.